Hi, I am Shebin Sam Abraham of registration number URK18CS277, and today I'm going to explain the ninth experiment, and that is page replacement algorithms. So today the main aim is to write a program to implement page replacement algorithms for least recently used, first in first out, and optimal replacements. So I'm implementing page replacement using these three algorithms, that is LIU, FIFO, and then optimal replacement. And it is done, and all the three are done in, you can use C or C++, but I have done this in C++ coding. So here are the three algorithms which I'm going to use: LIU replacement algorithm, FIFO replacement algorithm, optimal page replacement algorithm. Algorithms will be different, but the value which you're going to get is all going to be the same. So for LIU, which has not been used for the longest time in the main memory, is the one which is selected for replacement. FIFO means first in, first out, means which comes in and which goes at the end. Simplest page replacement algorithm. In this algorithm, the operating system keeps track of all the pages in the memory in a queue, and optimal page replacement means it finds out the lowest page fault rate of all algorithms. So let's just go into it and then we'll explain from that. So this is the program. For that is LIU page replacement algorithm. So hashing LIU string.h. Using namespace std find int or find LIU in time in 10. Yes, so in time in 10. Int of I, minimum is time of 0, position is 0, taking int variables, and then I've opened a file. For I equal to 1, I less than an I plus I, decrement of I, it's not decrement, prefix of I, that's plus I. Time of I is less than minimum is equal to time, and position of I, return position, and that is how to find the LIU. And then I have to open that in main function. So excuse me, in number of frames, number of pages, and then we are taking the count of it, counters, time, flag 1, flag 2, and then we are entering the number of frames, cn of frames, number of pages, cn of number of pages, enter the reference string, cn pages of I. And then we are using a for loop. For I equal to 0, I less than the number of frames, and plus I means frame of I equal to -1. That means the topmost position. For I is equal to 1 and I is less than the number of frames I plus, it prints the frame I variable that gets stored. And for I equal to 0, I less than number of pages, and plus I, flag 1 equal to flag 2 equal to 0. If frames of j is equal to pages of I, means counter plus, time j is equal to counter, flag 1 is equal to flag 2 is equal to 1, break. If flag 1 is equal to 0, that for j equal to 0, j is less than the number of frames, plus j. If frames of j is equal to -1, counter plus, frames of j is equal to pages of I, time of j is equal to counter, flag of 2 is equal to 1, break. Flag 2 is equal to 0, position find LIU using calling the function counter plus, false plus, and then it gets calculated over there. So total number of false occurred will be shown. So we just run the program and just see from that. Total number of frames I'm taking it as 3. Number of pages I'm taking it as 5. 7, 0, 1, 3, 6. So I took the variables as reference string as 7, 0, 1, 3, 6, and my frame 1, frame 2, frame 3 variable has been given over here, and then total page faults occurred is 5 as all taken. The total, according to the calculations, the total page fault in LRU, least page replacement. In that algorithm, I've given the details and my total page fault is 5. So using LIU has been done. Now I'm using FIFO rule, and then I'm going to use that. So hash include iostream.h using namespace std. Int main int of I, j, n, a of 50, frame of 10, number, k, avail, and count is equal to 0. Cout FIFO page replacement algorithm, number of frames, number of pages, enter the page numbers, all have been done. Then for I equal to 1, I less than n, I plus plus cn of a of I is I less than the number, frame of I equal to minus 1 goes to top position, and j is equal to 0. For I int of I equal to 1, I is less than or equal to number I plus plus, cout of frame of I, cout of n. For I equal to 1, I is less than equal to n, I plus plus, avail equal to 0. For k equal to 0, k less than the number k plus plus. If frame of k is equal to a of I, avail of 1. If avail is equal to 0 means it's like frame of j is equal to a of I. And if j of j plus 1 is percentage modulus number, it gets saved into j count plus plus. For k equal to 0, k is less than the number k plus plus. And then cout of frame, it gets printed over here. Cout the number of page faults occurred as equal to count. So let's just run it and check. So number of frames is 3. Number of pages, I'm taking it as 5. It's 7, 0, 1, 3, 6. It's just my mistake. Yes, so frame 1, frame 2, frame 3, the work has been done. Work and the calculation has been done, and the number of page fault occurred using FIFO is also 5. So here ends the FIFO execution, and now we just go to optimal page replacement. So let's get from that. So hash include iostream using namespace std. In number of frames, number of pages, frames, pages, temp, flag 1, flag 2, flag 3, ijk, position the maximum false, taking it as 0. Enter number of pages, the frames, the reference string. All has been given. Cn pages of I. For I equal to 0, I less than number of frames plus plus I frames. It's all like the same, the function. So for I equal to 0, I is less than number of frames plus plus I, frames of I equal to minus 1. For int of I equal to 1, I is less than number of frames I plus plus. Cout of frame is less than I. For I equal to 0, I less than number of pages plus plus I. Flag 1 is equal to flag 2 is equal to 0. If frames of j is equal to pages of I, flag 1 equal to flag 2 is equal to 1, break. If flag 1 equal to 0, for j equal to 0, j is less than number of frames plus plus j. If frames of j is equal to minus 1, false plus plus, flag 2 is equal to 1, break. And if flag 2 equal to 0 means flag 3 is equal to 0. For j equal to 0, j is less than number of frames, j plus plus j is decrement. It's prefix. So temp of j is equal to minus 1. For k is equal to I plus 1, k is less than the number of pages plus k. If frames of j is equal to pages of k, then temp j is equal to k, break. All the three brackets what I've opened before gets closed. For j equal to 0, j is less than the number of frames and plus plus j. If temp of j is equal to minus 1, position of j, then flag 3 is equal to 1, and then it breaks. So files are getting, for loops are getting opened, and they're checking out the conditions, and in the condition, Yes, so conditions, for loop conditions are getting opened, and then they're checking if each condition is working out. If one is not working out, it breaks, it goes to the next condition. Flat 3 is equal to 0, maximum of temp is equal to maximum of temp of 0, pose is equal to 0 for j is equal to 1, j is less than number of frames plus j. If temp of j is greater than maximum is equal to temp of j, position equal to j. Frames of position, page equal to I, false C out slash and j equal to 0, j less than number of frames plus j, C out of frames, and then gets counted over here. So just let's go directly into the program and we just get from that. That also 3. Number of pages are 5. Page reference string is, so I think it's 3. Yes, okay, I'm sorry, I just gave it as 3, that is my mistake. Just run again. 3, 5, it's 7, 0, 1, 3, 6. Yes, so here too, frame 1, frame 1, frame 2, frame 3 calculations has been done, and then total number of page fault is given as 5 over here. So this is how we do the replacement program, the least replacement program. I'm to implement the page replacement algorithm using the three algorithm, that is LIU, FIFO, and then optimal replacement. So using C++ or C. So this is how I do my, so this is how we do our 9th program. So here ends my 9th program. Thank you.